Here we've got a pretty complex shape. I mean, this is going to involve a lot of different things here. It's going to involve your knowledge of the Pythagorean theorem. It's going to involve your knowledge of finding the circumference, which is also the perimeter of a circle. It's going to be tough, but I think we can probably. So take some time, copy this problem down, paper somewhere. Just realize that not all the sides are proportionally correct, meaning this says it's 5 and so is this, but clearly I didn't draw them very well. But don't think about it so much as the shape, but just the numbers. Take some time to draw this out. See if you can figure out what the other sides are that aren't there, and then see if you can find the perimeter. Take some time to do this, and when you're ready to go, watch the end of this video. Alright, I'm going to start off real simple here with the sides that we should know just by looking at this. Okay, this one is going to be a big question mark right here, because there's not a lot that's going to help us figure this out. This 13 up here just means from here to here it's 13. I can use that, and I'll need that later for the Pythagorean theorem to get this, but not so much for this and this, because that's not really the outside, but I'll need it for the Pythagorean theorem. So I'm just going to go ahead, and if this is 10, I'm just going to say that this is also going to be 10, which is fine. And I'm going to say that this is going to be 10. I'm just going to say down to the half circle here, okay? Which means that over here is going to be 10. So all we're really needing right now is, because we've got almost everything, we just need the half circle part. We need the perimeter of the half circle and of the triangle. Okay, and by triangle I mean I'm going to cut this into a triangle. I'm going to assume that this is a right angle because we use the Pythagorean theorem on a right triangle. So I'm going to draw some dotted lines here and some dotted lines here. So now we've got a triangle. I'm just going to move this 2 right up here because this would be the same distance as this. I'm going to move, let's see, I don't need to move anything. I need to figure out what this would be. I know all the way across here is 13. Already right now I have 2 and I have 5, which would be 7. 7 plus 5, 7 plus 5 would be 12, so that's not going to be enough. So I think I'm going to need, let's see, 7 plus 5 would be 12. 7 plus 6 would be 13. So this is going to have to be 6 right here. Now we can do our triangle. I'm going to turn it like this for the triangle part just to give us our better look at what we're looking at here. Basically for this triangle, this is like the A and this is like the B right here. And we already have our hypotenuse. We already have our slanted side, so we have to do things kind of in reverse here. So I know that I'm going to have 5 to the second power plus something is going to equal my hypotenuse. And all the way across here is 13. 6, 5, and 2 would be 13. So that's going to be 13 to the second power. Okay. See if I can get this better on here. Okay. I can put this down in my Pythagorean theorem. I know that 5 to the second power is 25 plus something is going to be 13 to the second power. 13 times 13 is going to be 169. So now I need to figure out what this is and do the square root of it like we did with our Pythagorean theorem stuff. 169 minus 25 is what I'm going to want to do to find that. So I can just do 169 minus 25, and I'm going to get, what, a 4, and a 1. Okay, 144. Now, remember, that doesn't make sense because this can't be 144 if that's only 5 and that's only 13. Remember, all these are values that are to the second power, meaning this is to the second power, so we need to do the opposite, which would be the square root. 144 to the second power is 12. So our missing side here is going to be 12. And again, like I said, it's not exactly proportionally correct, but not a big deal. We've got 12 right here. Okay. Now we just need to work on the circle part. Okay, I'm just going to pretend, like in other examples, that this is a half circle, and I'm just going to make it into a whole circle here. And then in the end, we'll cut the circumference in half because we only want half of it. We don't want this part because that part's not any part of the outside. The perimeter is just the outside. Okay, so we have a diameter of 6. This is the same distance as this. So we have a diameter of 6. So it's going to be really easy to find the circumference. You just have to remember that the circumference is 3 times bigger than the diameter. Okay, or in other words, we could fit 3 of these diameters around the circle, basically. So we've got to get the circumference. Circumference equals diameter times pi, which we've talked about. And remember, pi we just used 3 for. So diameter times pi is going to be 6 times 3, which is going to be 18. So all the way around this circle is 18. Remember, we don't want all the way around that circle. We only want part of the way around the circle, which is going to give me a cut the amount in half. 18 cut in half is only 9. So I'm going to get rid of all this stuff because you don't really need it. And I'm going to say that around, just from here to here, the half of the circumference we need is 9. Now, we've got a lot of clutter on the board here, so we got to make sure we're only getting the outside of the shape. So I'm just going to follow along the line here to make sure we've got 2, 10, 12, 5. We don't need that 6 because it's not on the outside, so I'm going to get rid of that. Also that 2. Going down, we would have 10. Looping around, we would have 9. Up, we would have 10, 5, and 10. Now to find the perimeter of the shape. This is a tough problem, but I think we're figuring it out here. Perimeter equals. We just got to add them up. So I'm going to put a little mark by this 10 and know this is where I started. It's a nice strategy to use. 10 and 5 is 15, 25, 26, 27. Looks like we have, let's see, 27. Then we would have 37, 47, 48, 49, 54, 64, take around the loop, 64 and 10 would be 74, but we only want 9, so it's going to be 1 less, so it's going to be 73. Perimeter here is going to be 73. Now again, that was a pretty tough problem, but we broke it down into circle, triangle, and then we just had kind of our rectangular sides. This seems like a pretty tough job, but if you really stop, take some time to break it down, use all the things we've talked about because we've discussed all these things, this is something that's definitely doable.